Okay, now in this problem, we want to consider a long wire with a current I. It's moving this way, and the current is distributed uniformly over the cross-section of the wire. We want to find out what is the strength of the magnetic field 10 centimeters from the axis through the center of the wire, so this axis. So 10 centimeters from that. The radius of the wire is 20 centimeters, so we're finding the magnetic field at a point inside of the wire, and the current is 5 amps. So if we want to find the magnetic field inside the wire, we're going to have to use Ampere's law. Ampere's law is the integral of B dot dl equals mu naught times I enclosed. But now what's I enclosed? Well, they told us that the current is distributed uniformly over the cross-section of the wire. So if we draw an Amperian loop, now we're looking at the wire head-on, a cross-section of the wire. Let's say we draw a little Amperian loop inside the wire. The ratios of the area of this Amperian loop to the area of the entire wire times the total current is going to give us our current enclosed. So the area, our I enclosed, is going to be equal to the area of our Amperian loop, which is pi r squared, over the area of the total wire, pi big R squared for the radius of the wire, times the total current. So now that we have this, we can plug this into Ampere's law. Integral B dot dl is going to be equal to mu naught I times, these pi's just cancel, and we're left with little r squared over big R squared. Now let's evaluate this integral. The b is going to be constant here, so we can just pull it out. We're going to be left with b times the integral over dl, and this is going to be integrated over our Amperian loop, which has a radius of little r, so the total length is going to be 2 pi little r equals mu naught I little r squared over big R squared. If we divide by 2 pi r, we're left with the strength of our magnetic field, which is going to be equal to mu naught I over 2 pi r over big R squared. So now we can plug in our numbers, and so we have mu naught is 4 pi times 10 to the minus 7 times our current, which is 5 amps, times the radius of our Amperian loop, which is, we're trying to find the magnetic field at a point 10 centimeters, which is going to be 0.1 meter, divided by 2 times pi times r squared. The radius of our wire is 20 centimeters, or 0.2 meters squared. And if you plug those numbers into your calculator, you'll get that the strength of the magnetic field is 2.5 times 10 to the minus 6 teslas.